No, all right. That's okay. You can have a light homework night. That's okay. The Cartesian plane. The Cartesian plane. Is there a picture of it that we can look at? There it is, right down there, the Cartesian plane. Here's what it is. It's a number line with another number line. That's just a number line going both ways. It helps you navigate where things are on the plane. So this coordinate grid is often called the Cartesian plane. It's named after a mathematician called René Descartes, who was the first one to write a really good textbook or a really good manuscript about graphing points. It actually happened late. It was only a few hundred years ago. Now, that's why it took so long for us to get our act together on this planet. It took us that long to figure out, hey, maybe we'll do 2 axes. Then we can map things out. It wasn't long after that where somebody said, wait a minute, our world is actually 3 axes, X, Y, Z. And that'll describe the whole universe that quickly. Cartesian plane. So his name was René Descartes. Cartesian. He was French. The axis divides the plane into 4 quadrants. The point where the axes intersect is called the origin. Did you see the word origin in grade 9? Doesn't matter if you did or not. Here it is. Here's the word. It's called the origin. Horizontal axis is called the, well, it's called the x-axis. But I want to open your mind up to the idea that we're only using x there to learn about how axes might work. We could name that axis anything we want. We'll use x to start off with. And then the vertical axis is called the y-axis. Doesn't have to be. That's our playground. As we're learning about the Cartesian plane, we'll go x and y, just so we're all doing it the same and we can learn about this stuff. I hope that's either familiar, or you're like, if that's new, it's like, okay, I got some words for it now. Pretty good. The ordered pair of numbers that identifies any point is given as x, comma, y. We give the x coordinate first because it's usually the independent variable. Science people, did you talk about independent in science? Yeah, so usually, sometimes that's the independent variable. Unfortunately, science gets a little carried away sometimes and acts like every situation is going to be independent dependent. That doesn't have to be true, but lots of times when you're studying something, the horizontal will use independent, the vertical will use dependent. The x coordinate of the point is always written first, the y value is always written second. A dot is used to represent a point in the graph. So when we want to talk about a point, we use a dot, and then we sometimes use a capital letter A to represent a specific point. Does this all seem very familiar? Did you get to do this in grade 8? Was it a surprise in grade 9? Some of you did in grade 8. I know some grade 8 teachers don't get to it, and that's fine. We talk to them all the time, and if they're focused on integers and fractions, that's fine. We'll teach them the graphing when we get here. Well, here we go. Plot these points here. Let's see if you know how to do it. Yeah? Just take a second, in pencil, plot a few points, then we'll take them up and make sure your plotting points thing is okay. It's okay if it's not. We'll fix it right now. If it's not, good. I'll do a couple. So you can look up to see if you got them right. Okay, I did ABC. Is that what you got for ABC? Okay, what's the only thing that can go wrong here? What could go wrong? If somebody's going to make a mistake here, what are they going to do? Yeah, they switch which way they do it. So I've got a little memory tool for you. Just if you have a little brain cramp, well, which way to go? My family loves to take a few days and go to Niagara Falls. I don't know how we got addicted to this. It might be the little arcades down there. It might be the little dinosaur golf thing, or the giant Ferris wheel that nobody in my family has the nerve to go on, but we seem to like to look at it. And along the street is a lot of hotels. To get to our hotel room, we walk along the street to our hotel and then go up the elevator. That's the only way you can do it. You can't go up the elevator and then out the window to your hotel. Someone last year, someone raised their hand when I said that and said, no, there's a couple of hotels that are hooked up by tubes. Sometimes you can do that. I was like, okay, well, you're missing the point on purpose, I think. Most times when you go up to a hotel, you go along the street, then you go up the elevator to your room. Yeah, just a little memory tool so you can remember it. That's not why X and Y was set up like that. René Descartes, there was no elevators and no hotels in Niagara Falls when he was around. That's not why he chose the way he did. They just all agreed to go horizontal first, then vertical. Okay. 7, -4, so 7 down to -4. Oh, this is down to the parking garage underneath. Yes? Still fits my analogy. Sort of, I guess. 0, -3. Ooh, 0, -3. This is the most important point I've done today. I hope you've encountered that particular point. Not that number, but that kind of point before, and we'll talk about it in a minute. And 5, 0. Oh, I didn't label those last couple, did I? So 7, -4 was D. 0, -3 was E. And 5, 0 was F. Are we okay on graphing points? Even if you sort of forgot, now it's like, okay, I kind of got it. Couple of enthusiastic nods there. I hope that means I really get this, not that you're getting bored. If you're getting bored, don't worry. Brand new stuff coming very, very soon. Brand new, really cool stuff coming. You know, we're not going to spend much time on review here. Yeah. So, linear versus nonlinear. Do I have time to do this? Yeah, we'll do one more. A table of values represents a linear relationship if the first differences are constant. Did you use those words in grade 9, the first differences? Okay, good. A table of values represents a nonlinear relationship if the first differences are not constant. And what we mean by first differences is, as you go from 5 to 7, you go up by 2. As you go from 7 to 9, you go up by 2. As you go from 9 to 11, you go up by 2. These points are going up by the same amount every time, and if they do that, and I graph them, they'll form a line. Now, why are they called first differences? Well, technically what I should have done to get that 2, I should have taken the 7 and subtracted 5. I should have taken the lower value and subtracted the one above it. Why do I do that? Well, this all has to do with y2 minus y1 over x2 minus x1, and I'll give you an example. Let's imagine that you had $1,200 in your bank account, and I moved some money over because I owed you some money. And now you had $1,540. How would you decide how much I gave you? Well, you take the second one and you subtract the first one. So that y2 minus y1 stuff that seemed mysterious in grade 9 is nothing but saying, let's subtract them to find out how much they changed. That's all that was going on there. So I'll do it properly over here, okay? What you really should be doing is going 1 minus 4. Take the second one and subtract the first one to find out how much it changed. I know you can do them in your head probably, but there's a bigger idea building here. Something missed out on sometimes in grade 9 is that the steps help you build towards something bigger. So skipping the steps hurts your building situation. It's already nonlinear, by the way. I don't need to do all the differences in a nonlinear situation. Proving something's not true only takes one non-example. Proving something is true, you need everything. You need to do it all the way down, right? But I'll do the last one just to show. This one's non-linear because it doesn't go up by the same amount every time. If you graph these points, they wouldn't go straight up like this. Actually, there was a set of stairs on the deck at my parents' house that had this nonlinear problem. The last step didn't go up by the same amount. Whoever built this didn't know what they were doing. You should have seen people fall down every time because you're used to stairs being the same height every time. And then that last step isn't. It's a little shorter, and they'd trip over that last step because it was nonlinear. Those steps weren't going up by the same amount every time. It wasn't going in a straight line. The last one was like this, and it messed everybody up. On a scale of 1 to 5, how good do you think you are at slope? You can tell me. 5 fingers mean like I am great at this. 1 finger's like I don't remember this at all. So just hold up some fingers so I know what I'm doing with here. Interesting. Interesting. I'm leaving it for tomorrow. We'll stop there. Let's take a look at your homework page and see how far you can go, okay?